Now let's look at the properties of the function y equals square root of x. And the first thing we can do is we can think about what the graph of y equals square root of x looks like. And let's first do a table. So you have x and you have y equals square root of x. And the first thing you notice is x can't be negative because you would have a negative underneath the square root. X can be 0 and the square root of 0 is 0. X could be 4 and the square root of 4 is 2. And x could be 9 and that would be 3. So if you graph that out real quick, you have 0, 0. 1, 2, 3, 4, 1, 2 would be roughly there. And 9 and 3 would look like that. And you see basically what the graph looks like this. It starts off at 0, 0. That's the starting point. It's not really a vertex, but it works somewhat similar to vertex. It starts off at 0, 0. It starts to increase, but increases at a decreasing rate, so it gets flatter and flatter and flatter. The key is it never gets perfectly flat. So there's no. The key trick is that there's no asymptote here, right? So that's the basic graph of y equals square root of x. And now what we're going to do is we're going to look at the properties of that function. And let's look at each of those in turn. So let's do the graph out here. Right, this is 0, 0. And this is the basic graph there, y equals square root of x. And these are the properties here, right? So let's look at these first, domain and range, continuity, etc. So the first thing is domain and range. Domain is what x can be. If you notice, x starts at 0 and then becomes more positive, so the domain is 0, comma, infinity. That's what x can be. And notice it can be 0, so that's a closed bracket. And the range, if you notice the range starts, that's the y value, that starts at 0 and it becomes more positive, so that goes from 0 to infinity. That's your domain and range. Now continuity has to do with whether or not the function is continuous, or there are points of discontinuity, and that's continuous at all points in the domain. Or sometimes they'll say it's continuous from 0 to infinity. It means the same thing. Increasing or decreasing, so this is increasing at all points in the domain, right? Because if you notice y equals square root of x is always increasing. So it's another way to say it is increasing from 0 to infinity. And bounded has to do with whether or not there's a max or min values. If you notice, there's no maximum that y equals square root of x can be, but it never is less than 0, so we say it's bounded from below. And those are the first 4 properties. The domain and range, it's continuous at all points, it's increasing at all points in the domain, and it's bounded from below. Let's look at some more properties. The next one is extrema. If you notice, it has a minimum at 0, 0, right? Y takes on the minimum value at 0, 0. The symmetry, there is no symmetry. Right? This is neither an even nor an odd function, nor is there any symmetry of any type. There's also no asymptotes. Now that's an important thing to memorize. It's not necessarily clear the way that you drew it, but it's important to know that y equals square root of x continues to increase in terms of y and x. So there's never a y that is so large that you can't get it by y equals square root of some number. And the last one is in behavior. So let's look at in behavior. Normally, we would do end behavior. All the problems that we've looked at so far, y is equal to x goes to minus infinity, and the limit as x goes to positive infinity of square root of x. But if you notice, you never get to negative infinity. You start at 0, 0 and go here. So this particular part of the problem doesn't make any sense, right? Because x never goes to minus infinity. There's only an end behavior on the right-hand side, and as x goes to positive infinity, y goes to positive infinity as well. Not as fast, but it still goes to positive infinity. And those are the properties of y equals square root of x.